We are now going to compare two population means where the samples are independent, meaning that one sample is not related in any way to the other sample. There's no matching up. What we have are 14 rats that are being sent out into outer space. They make up our flight sample. And we're going to be measuring their red blood cell mass once they return. Then those measurements will be compared with the control group, the rats that don't go out in outer space, to see if there's a difference between these two. So what you're going to do on your TI-83 is, you press Stat 1 for edit and put the flight sample into list 1, the control group into list 2. It doesn't matter the order in which you put them in list 2 or the order in which you put them in the list 1. Unlike dependent samples where you had to be very careful of that. So go ahead, hit the pause button, enter the data in your calculator, and then start it up again so you can follow along. Okay, you're back? All right. Now, before we go ahead and do the hypothesis test, we better check and make sure the conditions are met. Both samples are simple random samples, so that's good. We also need to make a box plot and a probability plot for both sets of data. Now, before I make the plots, remember the two pitfalls we got to watch out for. I'm going to press Y equals, I got a bunch of stuff in here. I got to clear that out. So I hit clear, go down here, hit clear, so everything's cleared out. So make sure yours is too. Now I'll press yellow second key and Y equals. I got all these plots on. We better turn them all off. So press 4 and hit enter. So that takes care of the only two pitfalls that'll mess up our graphs. Press yellow second key and Y equals. Press 1 for plot 1. On is highlighted, so hit enter so it turns it on. Hit the down arrow key. Why don't we first do the modify box plot? Hit enter. Go down here. Let's do list 1, second key and 1. Frequency set to 1, and if there's any outliers, they'll be marked by that. We can go ahead and do the second box plot too at the same time. So let's do that. Press second Y equals. Press 2 for plot 2. Turn it on. Press the down arrow key. And the right arrow keys to hit the modify box plot. Hit enter. Hit the down arrow key. And let's make that list 2. So you notice I press yellow second key and 2 to get that. Everything's all set. Frequency set to 1. If there's any outliers, they'll be marked by that. Press the zoom key and 9. So we have both box plots showing at the same time, and there's no outliers. So that's good. Now let's make the probability plots. Those we'll have to do one at a time. Press second, Y equals. I'll go ahead and press 4 plots off, turn those all off. So I only want one of them on. Press 1 for plot 1. Turn it on. Hit the down arrow key. This is the probability plot. So I got to press the right arrow key repeatedly until that's highlighted, then hit enter to choose it. And let's go ahead and do this for list 1. So if you don't have L1 there, press the yellow second key and 1, hit enter. That's all set like that. Press zoom and 9. So it looks fairly linear. See, this is what it looks like in Minitab over here. So it looks very similar. Just on TI-83, we don't have the convenience of those boundaries. Now let's go ahead and do this for list 2, the control group. Second Y equals 1. All we have to do is go down here and change L1 to L2. So press the yellow second key and 2. That's all we got to do. Press zoom and then 9. It looks kind of linear. Notice how much easier it is with the Minitab output when you got those boundary lines to assure you it's okay. So that's the only problem with the TI-83. You don't have the luxury of those boundary lines. But the conditions have been met. So we can go ahead and do our hypothesis test, and this is how we're setting it up. Null hypothesis says there's no difference between the flight group and control group. The alternate says they are different, not equal to. So on our calculator here, we're going to press Stat, go over to Test, and what we want is two-sample t-test. See, the z-test is if the population standard deviations are known. Well, that's not likely, is it? So you're not going to use that very much. It's the two-sample t-test that we use so much. So I select that. Now, I don't want stats. I want to use the data in my list. So I press my left arrow key to highlight data and then hit enter to select it. And make sure you got list 1, L1 for list 1. If you don't have that there, press the yellow second key in 1 and hit enter. You want this set to L2. If you have something different than that, then press the yellow second key in 2. Make sure these frequencies are set to 1. Here we've got to get in the correct alternate hypotheses. Remember, it's the not equal. So let's go down there, highlight this, and hit enter to choose it. Pooled, no. So we're always going to say no. The only time you would say yes is if you knew for sure they had equal variances between them. Well, we don't know that, and it's hard to verify. So we're always going to be saying no here. With calculate highlighted, hit enter. We look at that p-value, 16.27%. That's a large p-value. It's larger than our significance level of 5%. So we failed to reject the null hypothesis. And as you can see, we've got that stated here. There is not sufficient evidence at the 5% level of significance to support the claim that there is a significant difference in red blood cell mass between the flight group rats and the control group rats. Well, you might be curious, well, what is the difference? Well, let's do a confidence interval. So press Stat, go over to Test, and scroll on down here where the intervals are. And what you want here is the 2-samp t interval. So select that. If you don't have data highlighted, highlight it, hit enter. And notice that everything is all set. The only thing you would need to change is the confidence level. Let's make it 95%. So enter 0.95. Go on down and highlight calculate and hit enter. So we are 95% confident that the difference between these two population means is between a negative 1.335 and a positive 0.23655. Notice the interval contains 0, so it agrees with the conclusion of our hypothesis test.